Good afternoon, all my dear students. Welcome to online class physics, class 9, motion chapter or kinematics. So already day before yesterday, we discussed in motion lesson three concepts. The concepts are rest, motion, and how rest, motion are relative. And I given some questions related to rest and motion and some examples on rest and motion relative also. So today we are looking how many concepts are there in this chapter. Now see, in this motion chapter we will learn rest, motion, and rest motion are relative. Already these three concepts are completed with some example problems. And after that, frame of reference. It's a very important concept in physics. And distance, displacement, speed and velocity, average speed and average velocity, uniform speed and non-uniform speed, and acceleration, equations of motion. There are four equations of motions are there. We will discuss clearly. And after that, ST graph. S means here displacement time graph. Using equations of motion, how we will draw this displacement time graph. And using these equations of motion, how we will draw this velocity time graph. And using these equations of motion, how we will draw this acceleration time graph. And lastly, uniform circular motion. These are the different concepts are there in motion chapter. So just I recall about rest and motion, how rest and motions are relative. Already I told relative means comparing. So rest means the position of the body does not changes with respect to time, and motion means the position of the body changes with respect to time. So now how we will compare, already I given different examples about rest and motion or relative. And today I am going to discuss about a new concept, an important concept, that is a frame of reference. I know you hear this word about a frame of reference. It's a very important point and a general point in physics. So for example, in a village, one school is there, and from 2 kilometer distance from railway station is also there. So here I will explain about some example about this frame of reference. See, let us assume that a school in a village is 2 kilometer north of the railway station. So in this example, the railway station is the reference point. Why? Because for example, some unknown persons are entering in that village. They don't know school. Some known persons are telling, yes, a school is 2 kilometer from railway station. Some known persons are telling that school is 2 kilometer distance from railway station. So for that only here, the railway station is reference point. With respect to railway station, the school is located. With respect to railway station, the school is located from 2 kilometers. So for that only, directly we are telling frame of reference is nothing but to describe the location of an object or to describe the position of an object by specifying a origin or reference point is known as the frame of reference. To describe the particular position of an object or particular location of an object, we are choosing this frame of reference, or we call it as a reference point also. For that one, you can see here the location of an object is school and reference point is origin. With respect to railway station, our school distance is 2 kilometers. So for that only, so to describe anything, we require some reference point. To describe anything, we require some reference point. This reference point, this phenomenon is known as the frame of reference. And not only that, just you can consider some 2D coordinate system and 3D coordinate system. For example, you can see some 2D coordinate system means it consisting two perpendicular axes, x, y axis. For example, like this, x axis and y axis. For example, if you consider 3D coordinate system, it having three axes, x, y and z axis. For example, I am taking the x distance is 2 meter and y distance is 3 meter and z distance is 5 meter. with respect to whom we are telling this 2 meter, with respect to whom we are telling this 3 meter, with respect to whom we are telling this 5 meter, with respect to this origin, with respect to this origin, the x distance is 2 meter, the length is 2 meter. With respect to this origin, the y length is 3 meter. With respect to this origin, the z length is 5 meter. So here this origin is known as the reference point or frame of reference. So for that one, like given a best example here, you can see in order to describe the motion of an object, we must specify its position with respect to an observer. So for that only, let us consider 3D coordinate system. It consists of three mutual perpendicular axes, x, y and z axis. The point of intersection of these axes are called origin or frame of reference point. With respect to this origin only, we will locate the position of an object. So for example, of course here x-axis is there, y-axis is there, z-axis is there. For example, here origin is not there. To whom we will describe this position of an object? To describe position object, we require some reference point, some origin, the frame of reference. So for that only, here this origin is known as the frame of reference. So indirectly, the simple meaning of frame of reference is to describe the location of an object or position of an object. Some specifying point is required. That point is called frame of reference. That point is called frame of reference or reference point. Yes, I hope you all are understood about this frame of reference. Next, I go with a small concepts, a small definitions like a distance and displacement. And what are the important relations about distance and displacement I will discuss today with best examples. You see, distance. You know very well, distance means the total path length covered by an body is said to be distance. Total path length covered by a body is said to be distance. We know about very well scalars and vectors. Already we discussed concept of vectors and scalars in 8th class itself. I think all of you know very well about, I hope all knows about scalars and vectors. Just I recall, scalar means a physical quantity which having only magnitude is called a scalar. What are the examples of scalars? Distance, speed, electric current, work, power. There are the different examples of scalars are there. Already we discussed briefly about scalars and vector. So here distance is also scalar quantity because distance having only magnitude and there is no direction for distance. For that only distance is a scalar quantity. And the SI unit of distance is what? Meter. SI unit of distance is what? Meter. Next, displacement. What is the meaning of displacement? The shortest distance from initial position to the final position is called displacement. So or change in position of an object is also said to be displacement. Change in position of an object is also said to be displacement. But here displacement is a vector quantity. Why it is a vector quantity? Because it is having magnitude and direction also. So for that only displacement is a vector quantity. And here SI unit of displacement is also meter. There distance SI unit is also meter. Here displacement SI unit is also meter. Why? Because of course distance, of course displacement, some length. SI unit of length is meter only. So using these distance and displacement, we will create some important relations here. So for example, in straight line motion, what are the relations of distance and displacement? In circular motion, what are the relations of distance and displacement? You can see, for example, I am taking some example 1. So it is a one straight line motion. It is a it is a B. A to B I am taking 2 meter. I want to calculate distance and displacement. You can see, just to solve problems, just you go through concept only. Don't buttify to solve problems. If you go through concept, you will easily do the problem. So distance. What is the meaning of distance? Distance means total path length covered by an object is said to be distance. Now see here what is the total path length? A to B only. There is no path, only one way is there. So for that only A to B is the here distance. Total path length covered by an object is said to be distance. So for that here there is no path, only single path is there. That is only A to B. How much length? 2 meter. that is distance is 2 meter. Next, displacement is nothing but what? Shortest distance between initial position to the final position. For example, if you take initial position is A, final position is B, or you can take B is initial position, A is a final position. What is the shortest distance? It is only shortest distance to reach B to A. What is the shortest distance? This is only shortest distance. Or to reach A to B, this is only shortest distance. For that, displacement is also 2 meter. So from above the problem, we will conclude in straight line motion distance is equal to the displacement. From above problem, we will conclude distance is equal to the displacement in straight line motion. So next problem also I will discuss. Next one is, I am taking one circular path with 2 points A, B with a radius R, and this assume that, let us assume that this particle also moving with time period T. What is the meaning of time period? Time period means time taken to complete one rotation or one oscillation or one vibration. So here a particle is moving along a circle of a radius R with a time period T. We want to calculate here distance and displacement for one complete rotation. So see, for example, here I want to calculate distance for one complete rotation. So we know it is a basic mathematics. For one complete rotation, what is the distance? For one complete rotation, distance is nothing but circumference of the circle only. So to complete one rotation, it takes 360 degrees. Here 2 pi is nothing but 361. Why? Because pi equal to 180 degrees with radius R. So for one complete rotation is nothing but circumference of the circle only. So it is a 2 pi R. Next, for displacement. Displacement is nothing but what? The shortest distance between initial position to the final position or final position to the initial position or change in position of an object. You can see here for circle it is a A, it is a B. So see, it is a one complete rotation. The particle is moving along reach again its same position. We call it is a one complete rotation. See here it is initial position A only, final position also A only. So change in position is nothing but final position minus initial position. For final position also A, initial position also A. Then A minus A is nothing but what? 0. So for to complete one rotation, displacement must and should be 0. Displacement is must and should be 0. So from this problem, from this example, we learn from above problem you can see here in a circular path or in a circular motion, distance is always greater than the displacement. See here it is a circular motion, it is a R circular path. So here distance is 2 pi r but displacement is 0. So for that only in a circular path or in a circular motion, distance is always greater than the displacement. Hence from above two problems we will conclude distance is greater than or equal to displacement. Distance is greater than or equal to displacement. Hence distance is never be less than the displacement. Hence distance is never be less than the displacement. Distance is always greater than the displacement. It never be less than the displacement in one particular case, that is straight line motion. Distance is equal to displacement. Thank you all of you.